My next presentation is really stepping back and looking at airtightness more generically and speaking about the issue of indoor air quality in buildings and just looking at some of the key issues that can arise and improving the health in buildings. Because airtightness, as I said earlier in my previous presentation, is a very emotive term, I think, and there's a lot of confusion about what airtightness is really trying to achieve. So my presentation now, I'll just recap very briefly on what airtightness is and its relationship with indoor air quality, looking at systems and materials used for airtightness, the potential sources of moisture in buildings and in structural materials, solutions to help offset volatile organic compounds or toxins getting into the building, and then I'll give a brief synopsis and recap. So to begin, I think there's a lot of confusion about healthy building or low energy buildings. If we look at this article from The Guardian, it says green buildings make you work smarter and sleep sounder, a study shows. But for every article like this that you might read, there's an article like this. Are our homes making us ill? The impact of energy efficiency on indoor air quality. So there's a lot of conflict in terms of what are we trying to achieve. At the end of the day, as I said earlier, buildings are for living in and for health and well-being. They're not energy incubators. So, but there's a lot of confusion about energy efficiency and energy improvements in buildings. And that may be down to a lack of experience and also bad experiences to some degree. And airtightness as a term, as I said earlier, it's very much about reducing gaps which shouldn't be there in the first place. It's not about hermetically sealing a building, locking the windows and making sure you can't get any air in. I recall one builder, we have a training centre where a builder came in with no experience with airtightness, and we were explaining to him what airtightness was. And he ran a blower door test in our training unit, and he was looking at us scratching his head, and then he went over to the door and opened it and he says, "Now look, now your airtightness is gone. What's the point?" So airtightness is a confusing term. I go back to my example earlier on. When I put over the curtains in my house, the curtains are still moving in front of the windows due to leaks. But when I live in an airtight house, when you pull over your curtains, they're not dancing in front of the windows because they're good windows and they're well installed with appropriate materials. And what about leaky buildings? Aren't they healthy? Aren't leaky buildings that allow the wind to blow through our plug sockets, our skirting boards and places like that very healthy living spaces? Well, in fact, mould growth has been a long-term issue. It's not a recent phenomenon. And in the UK and Ireland, you know, and all over the world, we're regularly breathing VOCs from mould or some level of mould. Mould is omnipresent, but it's a question of concentration and the amount we have and its intensity. And some people differ to their reaction to it as well. We see this building here, for example. This is a building that's extremely leaky and it had an energy retrofit, and a lot of work was done. It's a cavity wall where the cavity walls were pumped with an insulation. The insulation in the attic was upgraded. And following this, it's a neighbour of mine who asked, "Niall, could you have a look at my house? I'm having these mould issues. I've never had mould in my home before. I haven't started cooking more and I didn't get more kids that I know of, and the building is the same as it always was and nothing has changed. But I'm getting these mould problems." And when I looked at the building, you could see what happened was the thermal bridging was enhanced due to the cavity being pumped, a block closing the cavity at the top, at the wall plate level. And in the attic, the insulation was pulled back to allow cross ventilation as it was increased, resulting in a thermal bridge running around the perimeter of the building. So where there once was no thermal bridges, it was inefficient. Now, because insulation was sporadically installed, leading to differential temperatures, then we had these thermal bridges. Now, the local builder's solution was to core a second permanent vent in every room, because surely this is a ventilation issue, but of course it wasn't. So are leaky buildings healthy buildings? I would say all buildings need to really look at our ventilation strategies, not just airtight buildings, but a hole in the wall and a leak through a plug socket isn't a robust ventilation strategy. So air infiltration, this is uncontrolled, or drafts. Ventilation is designed, intended, and it's designed and intended, as I say. So the key is to build tight and ventilate right, get the balance right, to look at both. It's about building more air tightly, but ventilating well. And for ventilation to work, we need good air tightness. But of course, for air tightness to work, we need good ventilation. So that means, as I repeated from earlier, removing these red arrows and keeping the green arrows. And ensuring we've good attention to detail, applying materials, as Roman has already illustrated, And once we apply air tightness materials which are suitable and apply them correctly, we can help offset the risk of moisture getting into the construction, leading to mold within the fabric. So as bad as it is to have mold on an inner surface, it's worse when it's within the fabric where we can't see it until it becomes an issue. You can smell, and we have structural issues, and it can affect indoor air quality. In terms of air tightness, of course, energy is key, and to help offset fuel poverty against the people who need to conserve energy the most, air tightness is going to have a key role to play, because in the UK and in Ireland we don't have extremes in temperature, as I say. We have a relatively mild climate, but we do have a very windy and exposed climate, especially on the west coast and the northwest, and the influence of the wind is going to have a big influence on our energy bills. This graph just presents that in a pretty simplistic way, but what it shows is savings from making buildings airtight. This shows a two-storey house built in Ireland, 200 square metres, where you've an oil or gas heating costing 12 cents per kilowatt hour. And what this graph shows on the bottom left-hand side, on the y-axis, this is the cost or energy savings and the resulting money saved as a result of energy savings. On the x-axis, it shows the level of air tightness that you've improved. And this building has been ran through the Passive House Planning Package just to see how much the primary energy demand was reduced. What it shows is by going from the building regulations we have in the south of Ireland, which is 7, down to passive house levels of air tightness, the resulting reduction in primary energy demand led to a cost in space heating saving of over €5,000 per year. So if you take the materials required for air tightness on an average, say 3-bed semi-detached house, which seldom any more than €1,000, the payback in materials is quite fast. Now that's excluding the labour, but what I would say is air tightness doesn't have moving parts, or it shouldn't. Air tightness isn't about increasing wall thickness. It's not about adding complexity. It's something you do once, and you don't have to go back and change, hopefully. So it's a one-off investment, and it's something you only get one chance to do, so it's very much well worth doing. And we breathe a lot of air in buildings, and air tightness has a key role to play in improving air quality. We spend up to 90% of our time in buildings, and we breathe in over 3,000 gallons of air per day, per person. So ventilation is key, and there are many ways and means of ventilating buildings that I've already gone through in the previous presentation. But if we are using innovative technology, it's important, for example, with mechanical ventilation like heat recovery or other systems, that filters are maintained. And this is a major issue in industry, of course. Now, I think we're very familiar with this now. Many issues arising where systems are not being maintained adequately, and homeowners aren't getting adequate education on replacement of filters and changing filters and maintaining them. This is an image from a unit where after 90 days of service, this was the inlet for the filter, and we see here the amount of dust and debris and tar and carbon that was collected in it. Not a highly populated area, but the homeowner now changes the filter every 30 days as opposed to every 90 days after seeing that. So maintaining filters and changing them is very important. So in terms of ventilation systems and improving air quality, what about the materials we're bringing into buildings? Ventilation is important, but what about source control and looking at what we bring into buildings? At the beginning of the 20th century, we needed about 50 materials to build a building. How many materials do you think you need now to build a modern building? 55,000 materials are brought into and used in buildings now. So as we're bringing in more and more materials to buildings, these materials will potentially be giving off more VOCs or gases, be it pictures on walls, TVs, printers, mattresses, carpets, fire retardants. There's countless materials. And compounds found in indoor air have often off-gassed from building materials like furnishings. We've mentioned many of them already. Cleaning products. The most common gases found are carbon dioxide, carbon monoxide, nitrogen, sulfur dioxide, formaldehydes from floors, paints, carpets, VOCs, radon, ozone. And the most common suspended matter are asbestos, fibrous particulates from materials, bacteria, fungi, tobacco, and so on. So there are many potential toxins and allergens within buildings. If we look at research into asthma and allergies in Ireland has the highest rate of asthma in Europe, and the UK is pretty close as well. And 1 in 11 children and 1 in 12 adults in the UK have asthma. One of my daughters has asthma. And 3 people die every day on average from asthma. And in 2014, over 1,000 people died from asthma. Not only is it very sad and a tragedy for people, but also a huge burden on the NHS. And if you look at this global map from the UK Asthma Association, it shows in red locations where asthma is at its highest in the red stars. The blue stars are where it's at its lowest. If we cross-analyse this with airtightness standards in buildings internationally, if you look at the airtightness standard in Belgium, for example, it's quite onerous, but you have a blue star in Belgium. Sweden as well, you have a very high level of airtightness required as a backstop, yet you have the lowest rates of asthma. Whereas in the UK you have the leakiest buildings and the highest rates of asthma, and this is reflected in other countries too. Air quality has a big impact on indoor. It's one of the factors. We spend 90% of our time in buildings, and this is going to affect our respiratory system. We see here air leakage data report from Leeds Beckett University, which carried out a statistical analysis of airtightness testing on over 200 buildings. And we see here in the early 1900s, 1900 to 1910, the airtightness test result was relatively good. We can see here the airtightness was coming in at 10.5 for the buildings that they analysed. And then as we went through the decades, the air leakage rate went way up in the 1930s, 1940s, 1960s, and they only began to get to equivalent levels in the 80s and 90s. Why is that? Well, older buildings were monolithic walls, brick and stone with wet plaster, which was pretty airtight. So your leakage was coming through maybe the suspended floor, but put a carpet down and that helped improve that. And then the windows and doors had shutters maybe and weight boxes, and that allowed air infiltration. But the actual physical structure was inherently quite airtight. And then as time moved on, we moved away from the wet trades, put on block work with plasterboard, drywall, and we didn't have the wet plaster on the block, and then the buildings became a lot leakier as well as a result. So airtightness isn't relatively new. The difference is in the modern day, we now have a scientific measure for how leaky our buildings are, and we're measuring it. But we've always been trying to stop drafts getting into buildings. And the influence of improving air quality and ventilation in buildings is really incredible and can have a big influence on the budget for health spending and general well-being. This report from the NHS in Wales carried out a cross-analysis of hospital admissions to an ER room in a specific region, and anonymously cross-analysed this with houses which were refurbished with energy upgrades to ventilation. And it looked at the percentage reduction in admissions to ER, and it recorded a 39% decrease in ER admissions for cardio and respiratory issues post-upgrade. And where ventilation was improved, it was a 57% reduction in respiratory-related admissions, just by improving ventilation strategies. So we see the huge impact. This report was published this year. You can see it's unquestionable the benefit in improving ventilation strategy and energy upgrades in buildings. So is ventilation the silver bullet? No, as I've often said, and I said earlier, it is important, ventilation, but also why not look at what we're bringing into buildings as well? Why not reduce the source of toxins as well? We can't eliminate them completely in the real world, but we can help reduce them. So we can look at the materials we're specifying. Do they have approvals such as Nature Plus approval? In Germany, there's the Blue Angel standard for the Asthma and Allergy Association in Germany. Or there's the Sentinel House Institute in Germany, which is the equivalent to the Passive House Institute. It's a private group organisation which measures air quality and total volatile organic compounds in buildings when they're completed. And you get a certificate to be a Sentinel House, but you have to work within stringent standards for VOCs. In terms of materials like the ProClima system, for example, this A+ label is from France for off-gassing and toxins, so it doesn't contain VOCs or harmful emissions. As a rule, if you have to wear a spacesuit and have an oxygen supply tank to install a product, I tend to get raised questions about its influence on health. And as I said, Sentinel House has certified ProClima products as well. The Living Building Challenge is not UK based, it's an international standard from America, but it is really at the peak of accreditation for buildings products declaring their ingredients. So the Living Building Challenge has a red list of materials where you are not allowed to bring specific materials into the building. They include creosote, not surprisingly, and bromine, and PVC. Even PVC windows are not allowed to be used in a living building, or PVC on electrical cables, even. It's to that level. And flooring as well. It has extremely onerous levels in the red list. So if you look at the Living Building Challenge, you'll get a red list. And you also have a declare label scheme where manufacturers will have the opportunity to declare ingredients used in components, to declare they don't contain anything from the red list. So we see Proclima Tescon Vana profile, Intello as well has a declare label from the Living Building Challenge. And this is in the future, this is at the moment really at the cutting edge in terms of sustainability. There's also materials which can help reduce VOCs in buildings through what's called a photocatalytic action. This paint, for example, is called Air Fresh paint, which is a lime-based paint, which is activated when the sun hits it, and it helps break down formaldehydes, toxins, nicotine, and smells as well, which has been medically tested. We can see over time how it breaks down formaldehyde. There are various materials which have this property. I've used this product in one of the bedrooms for my children. Just helps, it's another way of helping improve indoor air quality, along with ventilation, of course. And also materials can help regulate humidity on surfaces. What this graph shows is, the blue curve is a wall that isn't insulated yet, an old stone wall. And we can see the humidity on the surface is almost reaching 90% at different times throughout the day. This is over a day. And what we see here is if the wall is insulated with 50 millimeters of calciterm, calcium silicate board. Calcium silicate is a lime-based insulation with extremely high humidity regulating properties. And we see now the surface humidity is staying at around about 65% by insulating the surface. So materials can help further reduce the risk of mold on surfaces. That's just another slide illustrating the Sentinel House approach, where we see the total VOCs allowable in a Sentinel House is very, very low. And this is more information on the Living Building Challenge. Housing standards, our approach in Ireland, for your information, we have the Home Performance Index, which was launched by the Irish Green Building Council, which I work with as well. And we launched that last year, and we see it now driving developers to move beyond just an energy performance certificate, or energy rating we call it in Ireland. So energy rating or energy performance certification is very narrow. The Home Performance Index looks at the vicinity of the building to amenities, to public transport, well-being, indoor air quality, and a lot of other factors. This is a certified passive house in Cork, which achieved Home Performance Index Gold, which is the highest possible standard with the Home Performance Index. It's by an architect called John Moorhead, a very interesting project. And finally, in terms of housing standards and comfort, the Passive House standard is actually a comfort standard. At the core, it's not an energy standard necessarily, it's really a comfort standard, which refers to ISO 7730. So our Passive House, for all the promotion of it, about energy performance and so on, which is very good, it's very much about comfort and maintaining comfort. Finally, this is a graph from a presentation which Archetype delivered a few years ago at the Passive House conference. And what it shows is their experience with indoor air quality in a range of schools which they've been working with over the years. And what we see here is on the y-axis, this is the CO2 concentration in the air. And the building regulations for schools state it must be below 1500. And you see that grey curve where it's peaking way high? This is a leaky 1970s school. And you see the bottom blue one? This is an airtight, certified passive house school. And which has the better air quality? And finally, in terms of air quality, there are tools now to help us monitor air quality in our homes. And there are more and more of these available, which can connect to our phones and tell you about the CO2 levels in your home, VOCs, humidity, and so on. To summarise, airtightness, it will determine the effectiveness of the insulation. It must be planned. A lack of foresight, as Alex very eloquently showed earlier, will lead to huge potential cost overruns. It must be attained with materials fit for purpose. planning and coordination is important, and meticulous workmanship is crucial. In terms of air quality, leaky, well-insulated buildings lead to poorer indoor air quality. So a leaky building is not necessarily a healthy building. It's about building tight and ventilating right. And whether a building is airtight or not, ventilation is essential, having a robust ventilation strategy. As building regulations improve and Partel improves for insulation standards, that must be done in step with improvements in ventilation standards. And in retrofit, that must be particularly handled with care and must be viewed looking at retrofits as a whole, as a system, rather than just taking airtightness and isolation as with any building, but in particular in retrofits. And where mechanical systems are introduced, they work extremely well, but commissioning is crucial, that it's done well, and also that it's maintained by the homeowners, and that they understand that they have to change filters and maintain the system. For a healthy population, we must start with healthy homes. And in terms of further reading, the UK Centre for Moisture in Buildings, which we're involved with on a number of advisory boards, have published this document, Health and Moisture in Buildings. It's freely available and it's an excellent document I'd highly recommend. And the UK Green Building Council have also published this document, Health and Wellbeing in Homes. And there's other information there which is available. Thank you.